The Babylonian calendar worked in the unit of 60. Year had 360 days. Each day was divided into 24 hours, each hour into 60 minutes, and each minute to 60 seconds. And this form of counting has survived for 4,000 years. We've been traveling across the ancient world to see different forms of numerals. We could keep going. The Mayans, the Greeks, and the ancient Romans developed their own unique counting systems. We've dropped the Mayan and the Greek ways, but we still use Roman numbers today, for clocks, to denote centuries, to suffix the names of kings and tombstones, etc. Let's now see how numbers come naturally to most of us. Even animals. Take a bird. She has a nest with 4 eggs. If you take one out, she may not notice. But when you take 2 out, she will desert the nest, because she has realized that there is a predator somewhere close. This means she can tell between 2 and 3. Sounds random? Well, let me share a more documented experiment done on bees by a group of scientists from the Vision Center in Australia. The scientists showed the bees a number. So if it was 3, there would be 3 dots. Then they flew through a tunnel into another chamber. Here they were faced with 2 forks, one with 3 and the other with some other number, say 4 dots. Now, if the bee picked the same number, in this case 3, the scientists added an incentive. They got a hidden sugar solution as a reward at the end of the fork. If they chose the wrong pattern, they were released and allowed to try again. And the bees did pretty well. They were more often than not chose the same pattern that they had seen earlier. To show that they were recognizing numbers and not just shapes, the scientists would vary the representation of the number. So they would first show the bees 3 dots, and then the next fork would have 3 stars. By the end of the experiment, the scientists were able to conclude that the bees could count till 2, 3, and sometimes till 4. Similar experiments have been done with chicks, pigeons, and monkeys, to name a few. And from this, we are able to conclude that animals are able to discriminate between small numbers. What about babies? And I mean tiny ones who haven't started walking or talking and clearly haven't been taught numbers. Let's look at an experiment done by Karen Wynn, a scientist in the US, with a group of 32 5-month-old infants in 1992. Let us see how young Vani reacts to the same stimuli. She is first shown a doll that is then hidden behind a screen. Then another doll is added to the one behind the screen. Now if Vani sees a number she expects, she does not react. So if there are 2 dolls behind the screen, which is the possible event, there is little reaction. However, if there is a number that she does not expect, she clearly notices. So if there is 1 doll behind the screen and she hadn't seen the second being removed, she would be surprised. How do we know that she has noticed? Well, because she looks at the objects for much longer. Similarly, if there are 2 dolls to start off with and one is removed, Vani is able to perceive the difference between the right answer and the wrong, which implies that infants are capable of distinguishing between small numbers. This result caused much consternation when first published and had many disbelievers, but independent research from other sources have confirmed Wynn's findings. Great. So it looks like humans and animals both have an innate number sense. But as mankind progressed, what they developed was a numeral system to make sense of these numbers. we are back to exploring the evolution of the numeral system. We've already seen how Egyptians, Babylonians, Incas, and Romans handled numbers. But none of those systems are very much in vogue today. The system we use today, the system the whole world is familiar with, is known as the Indo-Arabic system. To explore the system, we'll need to travel to ancient India and explore the mathematics of this region. So what kinds of numerals were used in India? Some early evidence is found on columns erected in India by King Ashoka in about 250 BC. Similar inscriptions are found in caves near Pune 100 BC and Nasik 200 BC. These numerals appear in a script called Brahmi. The Brahmi script, which had notation for numbers 1 to 9 as well as distinct symbols for a host of other numbers. However, what they didn't use was a zero. One important source of information on this topic is the writer Biruni. Biruni, who was born in modern-day Uzbekistan, came to India first in 1030. Through his numerous visits, he studied and documented the Indian number system. He realized that number systems often varied across different regions. For example, the Tamils in the south of India had also evolved another numeral system, the Tamil Brahmi numbers. Various stone inscriptions and pots show evidence of this, and most of this inscription dates back to the 1st and 2nd century AD. Now all these numbers eventually evolved into what came to be known as the Indo-Arabic numeric system.